Martin ended with a list of people he would like to thank. For us, the smart card and cryptographic hardware domain is already running since 2002, so a lot of people collaborated, not only here from Brno, but also from UCL in London and other places, so I definitely would like to thank all of them. Our lab, the CRoCS Labs, is here at Masaryk University and is doing various things. Usable security is one thing. Second thing is related to applied crypto and applied crypto in limited devices and cryptographic devices like smart cards. The reason why we got into the field was in 2002, our Czech National Security Agency, it's not the same as US NSA, asked us to evaluate some smart cards for them. So we did that. We basically tried to break into, and then we picked some of these. And then we got hooked, at least I did, and a lot of my colleagues as well. Part of the reason is that the smart cards are very pervasive. They are everywhere. You have them in mobile phones, and you are using this for payment. Nations are moving towards the electronic IDs and authentication tokens. There are many, many examples. At the same time, this is not really open, free, friendly domain. It's very closed, as the hardware industries tend to be. Even if you would like to just see the detailed specification, you need to sign NDA. And this is especially not nice to academia, where we would like to publish, right? And make the data public, not keep it secret. Still, the situation is so if you would like to buy some used smart cards in smaller quantities, you just can't. You nowadays can buy some older pieces, but not the newest one. But maybe this is not an issue, because all these smart cards and related things are security certified. There are common criteria certification. There is a NIST FIPS140-2 certification. So maybe we are just fine. We don't need to investigate these devices, right? We still think there is a reason to investigate these devices. Right now, the cryptography is mostly in a stage where on the mathematical level, it's somewhat okay. We now know how to design things so they are very hard to break. On the implementation, that's a different thing. We are still struggling with a lot of implementation bugs while making from the mathematical level to the implementation level. And when the device is closed sourced, it's smart card, black box device, there can be, of course, there is less scrutiny overall, and there can be potential backdoors and so on. So we do like to investigate this. And maybe you, as a customer, buying a lot of smart cards, you would like to learn what you are actually buying, not just trusting the certification that happened 10 years ago. So our driver motivation is, okay, let's do the analysis as far as we can get without signing NDA. And then if we will find the bug, then we will report, of course, make the library a bit safer, and we will have a paper published. And even if we will not find the bug, which happens, we will have more confidence in that device or library. And also, we are trying to maintain and release the testing tool we used, because then the same testing tool can be used again and again against the other devices. So the security certification, I already touched that. My belief is that it's definitely not transparent enough. So this is just a random example. I have nothing against the Panasonic in this case. This is the extract from the security certificate. How many of you ever read something like Common Criteria Certificate for Device or NIST FIPS certification report? Okay, bunch of you. Okay, this is very common. You can read quite nice details, and when you will get heated, like, okay, I finally will learn how they are doing this against simple power analysis or differential fault induction and so on, okay, they will refer you to reference 6 in this case, and this reference 6 is here, but it's confidential document. It was handled to certification laboratory, but it was not, it's not available publicly. So we are missing the crucial part for assessment. If you will like to learn what the certification laboratory actually did for the steps, how they verified the device, what tooling they used, what was the setting they used, you're out of luck. This is frequently not written anywhere. the certification even reverts obscurity to some extent. Like, if you are not providing free samples, good, because it's harder for an attacker to get the free samples and start attacking your system. So basically, by all of this, we are forced to work in a black box analysis model. So we are just getting the cards. We can use the public interfaces that are there, but everything else is up to us. It's black box. So over the time, we collected a large number of cards. We now have even more than these. And we are basically running our analysis against all the cards we are able to reach. So how you can analyze smart card if it's just a black box one? So of course, you can get the public API, and you can try to fiddle with that. Especially, you can craft a large number of inputs, test inputs, especially the corner cases, and you can start to analyze how the device behaves for these corner cases. You can look at the data returned, errors, timing. Sometimes you can plug oscilloscope to see what is actually happening on the device and so on. So you can learn something. It's black box, but you can learn something. And you are not running this against one single device. Because we have the database of now 50 cards maybe, different cards, so we can run against all of them. So it's kind of fishing for the bugs, but we are using the tool, which is open source, can be used by others, and we are just running the tool against all the cards. So our cycle is quite simple. We are gathering a large number of data to have reasonable statistics. Then we are analyzing this data. And for a lot of things in cryptography, the expectation it's random data or indistinguishable from the random data. So the observed distribution shall be uniform. And once you will see something that is not uniform, it's not guaranteed that you will be able to exploit it, but it's interesting and you can start looking at that in more detail. So this is what we are doing. So one example. At some point, we took more than 20 software libraries, 16 smart cards, and led them to generate a large number of RSA keys. So the cards were generating for several months for some of them, and we got 60 million key pairs for RSA. And then we performed various analysis. It's not that important what we actually did. If you're interested, I'm very happy to talk with you. But we were starting to see differences. We are starting to see that, okay, these are random RSA keys, but we were able to say whether the random RSA key is coming from OpenSSL library or this particular smart card, and that was surprising. So we basically tracked down the reason, and the reason was for RSA, you need the primes. And how to decide whether the particle number is prime or not, there are various algorithms. Different libraries use different algorithms, and this thing was somehow going into the primes, and because the public key is just a multiplication of two primes, it was also going to public key. So at the end, you can take a certificate, extract the public key, look at few specific bits, compute something that is really quick, and then get the answer. It was generated by OpenSSL. Okay, so, but maybe this is just for curiosity, right? Good for academic paper, but maybe not really practical. But there are some practical use cases. One of this is, how many of you know what is currently used on internet as a cryptographic library, most prevalent? Likely, if you will start guessing OpenSSL, you are right, because so many people are using OpenSSL, but how many keys are actually exactly generated by OpenSSL? Nobody knew before this technique, because now you can just take these keys. There are scans over the whole IPv4 space, and now people are adding also some scan of IPv6 space, part of it. Then you can start using this technique, and you will learn. So we are more and more dependent on OpenSSL. Microsoft is the blue one. If you are wondering what is this gap, it's simply the mistake in the collection script. The people that were doing these scans, they just made the mistake. They were not able to establish the connection to Microsoft IIS server and failed to gather keys from them. This previous picture ended in 2017 when we published the paper, but we are still collecting the data, and every 2 weeks we are updating this. Now it's sudden increase in number of keys in these data sets. The reason is that they started to crawl also IPv6. But we were unaware of another thing that was hidden in the data even in 2016, but only in 2017 we figure out that there is one source Infineon library on Smartcards. That is stranger than others. They were more different than others. Every statistic we applied, we were able to get that this is somehow different. And the difference, at the end, we tracked down that they were not taking the random primes, but instead of their primes had this formula. The reason for that was quite benign. They would like to speed up the generation of primes, but it turns out that you can attack this kind of keys if the prime is with this type. And the estimated 1 to 2 billion devices, the smart cards, were affected. And by affected, we mean that you can practically factorize and get the private key for the 2K RSA, which is commonly used nowadays, just based on the public key. And Estonian agency did that for price of several thousands euro. And just to give you some idea how bad it is when you have primes like that, this is the guesstimate for number of CPU years you will need to factorize full 2K RSA key, which is well generated. And this is the time for Infineon primes or Infineon keys. And what is worse, it's perfectly parallelizable. So you will just throw more cores on that, and you will get the result. This is the way how Estonians did that. All the public keys had the specific fingerprint that you can use to track down the original library. And for example, Let's Encrypt will not certify your key if this fingerprint is found. Yeah, and NIST in annual report said that this was something that had serious impact. You would think about smart cards, but it turns out that trusted platform modules are smart cards as well, just tied to a motherboard. And it turned out that Microsoft is storing the decryption keys for BitLocker using the TPM. And if you can decrypt the key that the TPM is using, you can get the decryption key for the whole disk. So there were a bunch of different domains that were affected. Just side note, this is a vulnerability from 2017. And if you were using the signature key that time, likely your certificate is already revoked. So even if the attacker will now factorize the key and then do the signature, you are fine because the certificate is already invalid. But this is not true for encryption of the data. Basically, if someone was collecting all the encrypted data and just waiting that maybe in the future something like this will happen and I can then get the private key, then they can get decrypted data. So this was for RSA. There is another important domain in asymmetric cryptography, which is called elliptic curve cryptography. And we applied basically the same technique. We got a bunch of libraries, got a bunch of cards, asked them to do a lot of signatures, and then measured how long will it take to finalize the signature. And a lot of cryptographic libraries are nowadays written with a mantra of constant time execution. So no matter what is the data you are processing, it shall take the same time, except for some noise. And basically, this is what you do expect, and we saw that for majority of the libraries. So basically, no matter what was the data, it was the same. But at some point, we saw something like this. What you are seeing is the most significant byte, the value of the most significant byte on x-axis, and on y-axis is the time it takes for signature. So there is a dependency between something that is used during the signature and the time. This itself is not clear path to exploit, but fortunately for us, unfortunately for the developers and producers of these cards and libraries, there was already published attack how to exploit this small leakage so you can get the private key back. And it turns out that a lot of libraries are vulnerable. We applied this to some smart card which was certified to EL4+, and there are a bunch of other controllers with the same technique used inside the chip, and also the libraries like Oracle, JDK, and other implementation were vulnerable as well. So for the smart card, all it takes is 20 to 30 minutes to measure enough signatures and then compute the private key. So that was another example of technique. We measured a lot of data, analyze any bias found, and then reason whether it's vulnerable or not. We are trying to keep tooling. So there is a short list of tools we are having and we are using. We are not only trying to maintain the tools, but also we are trying to maintain the data obtained by these tools and we are making them public. So the last part is about the certificates again. So those of you that were reading sometime in past some common criteria certificate may recognize this. This is another random example certificate. Certificates are really nice because for me, I'm not going to sign the NDA with the company, but I can read the certificate and there is a lot of interesting details which are otherwise unavailable, like the certification reports, libraries, the version of libraries, the techniques on high level they used, and so on. The issue is that there are right now more than 4,000 common criteria certificates with a lot of updates, so at the end it's like 10,000 PDF files and it's really hard to read. So you can apply some clever machine learning like word cloud, and you can learn that it was certified by BSI, it's common criteria, and there is some security target. So great, but this is likely not enough. We can get more information from the certificates. So what we are trying to do with this line of, let's say, work or research is to get more information from what is already available, shine more transparency on the existing common criteria certification. There is a portal, common criteria portal, where you can get all these PDF files and so on, but not that much more information. But you can like crawl it, try to extract, try to do some natural language processing, and try to get information out of it. Our goal, the first main goal, is to make big JSON with the data reasonably automatically searchable. Just example what you can get out of this. Once you are able to parse the certificates, you can say which type of devices was certified in particular year, and then you can like start drawing the graphs about the trends over the time. So you can see that in a common criteria scheme, most of the devices are from the smart card area. A lot of them are from network-related, like firewalls and so on. Other devices. So it seems that the common criteria is used for other things than the originally planned areas. If you do have the certificates, you have the ID of the certificates, you have the text, you can also try to look at what are the relations between the different certificates. And you can, for example, figure out that this certificate is referencing this one, and this one is referenced by 2 other certificates. So that's nice. Sometimes it's a bit more complex. This is helpful if you will learn that, for example, this middle certificate is now vulnerable. There was some bug found. So you can then check quickly what other might be dependent on vulnerable thing and then look for that. Reality is that frequently it's like this, like a mess, a lot of cross-referencing certificates, so we still need to do some work on better visualization and analysis of this. You can, for example, compute how many times are different certificates referenced. And based on that, you can get the certificates that are really important because all other people are talking about them and potentially using them in their products. You can go deeper and also investigate indirectly reference certificates. And the certificate which is the most referenced, 93 times, is Smartcard by Infineon with this particular library. And guess what? This is the library that was vulnerable with RSA key generation I was describing before. So this is my last slide. Initially, I was naive and I thought, okay, it's certified, so it's secure. Now I know this is not the case. My perception with respect to secret design and the damage is that, okay, if it's the secret design and bug is inside, it takes just longer for the bug to surface. And then the device is more widespread and maybe the damage is higher. Certification itself is important. People are talking more about the certification, not less. But we need more transparency and more automatization, because what works for military devices or smart cards doesn't necessarily work for something that is changed 10 times a day, like software deployed somewhere in a cloud. We are trying to do tools that are open source and everyone can run and can be one part of this more transparent certification. Thank you very much.
Questions?
So some of the techniques you use require a lot of time to gather data. Are there any that could instead be used, for example, in CI systems, so that libraries don't regress without taking forever?
So particle technique takes a lot of time if you are interacting with the real hardware, with the smart cards. Then it takes weeks, maybe months to get million keys. For software libraries, it's not an issue. You can get million signatures, million keys in an hour or something like that. So for this, it's way easier. Smart cards are like particularly slow devices, I would say. So it's argument we are making here is not that our type of analysis can find and prevent all the bugs, but rather that this is something that, like, nowadays people use continuous integration, they are using unit tests, and they are just checking all the time. So let's automate what we can automate with tools like that. And then let the certification laboratories with the human labor to do the more difficult tasks of analysis.
Hey, quick questions. Are the scripts you use to download and parse commoncriteria.org portal open source?
Not yet, but they will be. And I'm not saying that it's just like, I don't like to make it open source before I will fix the APIs a little bit and so on. But they will definitely be together with the data.
Okay. Great, thank you.